On today's episode, it's on. The Bezos-Musk rocket engine battle begins.
Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today.
Elon Musk and Jeff Bezos are famous for building titanic corporations like Amazon and Tesla, but they have interesting hobbies. We all know that they build and launch rockets, but the critical aspect of both private space programs are the real goal of their projects, that's to commoditize spaceflight. In a sense, spaceflight has already been commoditized, as several private and quasi-private programs will launch almost any payload at competitive prices, and frequently on customer-specified timelines. That created the private communications and Earth resources satellite industry, but tens of millions of dollars per launch meant that the business case for private spaceflight was restricted to companies with big-dollar business models like the major telecoms. Today, that's changing with the reusability of SpaceX rockets and a new generation of small-sat launchers that use advanced fabrication technologies like additive manufacturing. But it takes a lot of power to launch something into Earth orbit, the power that can accelerate a mass to over 17,000 miles an hour, and that means powerful engines. SpaceX uses reusability to recover the first stage and its associated engines, reducing costs. But Blue Origin has developed a high-tech engine which the company has now sold to an outside space launch operator, United Launch Alliance. The first pair of BE-4 engines has been delivered to ULA's Decatur, Alabama factory for integration into the company's Vulcan rocket. While Vulcan uses a pair of BE-4s, Blue Origin's own New Glenn reusable booster will use a cluster of 7 of the engines. The Vulcan was originally designed to use Russian-supplied RD-180 staged combustion engines, which have also been used with Lockheed Martin Atlas boosters beginning in 2000. Political considerations in the use of Russian engines in American spacecraft have been an issue since Russia's 2014 annexation of Crimea, and the development of US-derived technology removes the difficulties in licensing production of the RD-180 domestically. The BE-4 is a large engine producing 550,000 pounds of thrust and is designed to be highly throttleable, necessary for soft landing of recoverable boosters. The engine burns liquefied natural gas instead of the traditional rocket-grade kerosene, a choice made for clean burning characteristics at low throttle settings, but also to harness the boil-off of LNG and propellant tanks to enable pressurization without external helium systems. Like the RD-180 and the SpaceX Raptor, the BE-4 is a staged combustion design, meaning a small portion of fuel and oxidizer are diverted to a pre-burner, where combustion gases are used to power the engine turbopumps. Pre-burner fuel ratios are typically oxygen or fuel-rich, and the combustion gases are poured into the main engine combustion chamber, creating a closed cycle. Closed-cycle systems are more efficient than older designs, which dumped combustion gases overboard or used independent power systems to drive the pumps. Like most engine design, rocket engines are a series of design compromises, and the use of oxidizer or fuel-rich mixtures, as opposed to perfectly stoichiometric ratios, are used to control temperatures and allow the use of combustion chamber nozzle materials that can be cooled regeneratively with propellants. Over at SpaceX, the Raptor series engines, full-flow staged combustion cycle designs, are also in series production at a 7-unit-per-week rate. Announced thrust for the Raptor engines are 500,000 pounds, making both the Raptor and the BE-4 very similar in performance as booster engines. Rocket engines, however, are not mass consumer goods, and with overlapping development and production of engines of similar performance, whose annual demand will be measured in the dozens rather than hundreds or thousands, it may not make strict economic sense for both Blue Origin and SpaceX to independently develop these rocket engines. While a joint venture would logically make sense, the likelihood of a Jeff Bezos-Elon Musk joint venture in space technology is still remote. A Silverado and an F-150 are pretty similar, but Ford and GM will likely never share engines.
Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.